Chapter 7, we're still looking at exponential functions. We're going to go ahead and start looking at a different type of sequence than we've looked at before. So today we're going to be identifying and generating geometric sequences. You'll remember not too long ago we did arithmetic sequences. This is another type of sequence, but it's still a sequence, a list of numbers that follows some type of rule. We're also going to look at how geometric sequences relate to exponential functions. And I think as soon as we see the formula that helps us to generate those sequences, you'll see why this ties in with the exponential function chapter. So let's define what a geometric sequence is. So in a geometric sequence, so the first term is not going to be 0. Okay, so that's, if you ever see a sequence that starts with a 0, it's not geometric. The first term is not 0. Now that means it can be anything else, but not 0. And each succeeding term, in other words, every other term, the next term, the next term, the next term, each succeeding term is found by multiplying a common ratio that is also not 0. In other words, we're going to have an initial term, a first term, and then we're going to multiply that first term by something to get a second term. Common ratio says this could be a whole number or this could be a fraction, but it's going to be something that's not 0. So in this example, this is a geometric sequence, and so to get from, using multiplication, to get from the first term to the second term, we multiply times 5. And then to get from the second term to the third term, we multiply times 5 again, and then times 5 again. And if we wanted to keep generating numbers, we would keep multiplying by 5. So the next one would be 625. And then times 5 again, right, would be 3,125. And if we wanted to go times 5 again, right, we could just keep creating this sequence by using that common ratio, 5 in this case, and multiplying it by each term to get the next term. So we're going to look at a couple of sequences here, and here's what we're looking for. We're going to determine whether each sequence is an arithmetic sequence. In other words, did we add or subtract something to get from one term to the next term? Geometric, did we multiply by a whole number or a fraction to get to the next term? Or neither, right? So it's either going to be an arithmetic sequence or geometric sequence, or neither. And the way we determine that is by what gets me to the next term. Does adding or subtracting something? Does multiplying something? And that's going to determine which type of sequence it is. If it's a sequence, we'll then find the next 3 terms. All right, so here's our first sequence. So I'm going to just kind of start playing with how I got from the first number in the sequence to the second number of the sequence. So we might say that we subtracted 32 to get from the first number to the second number, because that's one way to get from 64 to 32 is we subtract 32. But does subtracting 32 get me to the next number? The answer is no. So then we're not going to subtract, we're not going to add or subtract something. So this has to be either geometric or neither. Okay, so from 64 to 32, what about if we multiply times 1/2, right? 64 times 1/2 is 32, so that one works. Times 1/2 is 16. Times 1/2 is 8. So that ratio, 1/2, gets me to the next term. So this is going to be geometric. Okay. And for the next 3 terms, we're at 8. So 8 times 1/2 would be 4. Times 1/2 would be 2. Times 1/2 would be 1. ... Right. That sequence continues. We don't need to know them, but this sequence would continue. So what about this one? Okay, from 16 to 22. How would we get from 16 to 22? I really hope this is addition or subtraction, because to multiply something times 16 to get 22. That would be an interesting number. I'm not sure what that would be, but it does look like I can add 6 to get to the next term. And then if I added 6 again, and if I add 6 again. So this one is an arithmetic sequence. An arithmetic sequence with a common difference of a positive 6. And then to get the next 3 terms, we would add 6. And we would add 6. And we would add 6. ... Okay? Now, hint, hint, hint. We've used geometric and arithmetic, so the next one is probably neither. But let's look just to make sure. All right, so from 3 to 7, that's not easy multiplication. So let's see if addition or subtraction would work. So 3 plus 4 gets me to 7. But then from 7 to 12 is plus 5 and plus 6. So this is a sequence, but it doesn't fit either one of our patterns. It's not arithmetic, it's not geometric. So this one is neither. Okay. Now I'm gonna let you do a few. Okay. Arithmetic, geometric, or neither. Here they all three are. Answers will pop up pretty quick. Here they all are. Answer geometric, arithmetic, neither, and then give the next 3 terms. All right, on this first one, we are multiplying times 3, so it makes it geometric. Our next 3 terms, 27 times 3 is 81, times 3 is 243, times 3 is 729. All right, the next one. We're adding 5, adding 5, adding 5. So this one is going to be arithmetic. And our next 3 terms would be 0, 5, and 10. Okay. Now the next one, we feel like it's probably going to be neither, but we're still going to look at it. So 2 to 8, like we could be multiplying times 4, but then that doesn't get us to the next number, so we're not multiplying times 4, but we are adding 6, and then we're adding 6 again, then we're adding 8, right? So now that puts us right back at neither. Okay. So here's our formula, and this flashback to arithmetic sequence and the formula that we had for an arithmetic sequence. It started off with a sub n equals a sub 1 plus the difference times n minus 1. And you're going to notice some common pieces, right? One, like we're adding a common difference. N minus 1 is that piece that let us get from one term to the next. So this was the arithmetic sequence formula. What you're looking at on your screen right now, though, is the geometric sequence formula. So we still need to know a first term, and we need to be able to figure out the ratio, the number that we're going to multiply to get to the next term. And the an and the n minus 1, like those are just pieces that are going to fall into place as part of the pattern, right? So here we go, and this one's a little difficult, so I'll walk through this one, and then we'll give you one maybe a little easier to look at. So a sub n equals, right? A sub n doesn't change. We're looking for the nth term, so that's why n is still a part of my formula there. So a sub n equals a sub 1. So the first term is -6. -6 is going to be multiplied by my common ratio once I figure out what it is, and that's going to be raised to the n minus 1 power. And that's the piece, the raised to the n minus 1 power, that's the piece that puts this into the exponential category. Okay, so first number is -6, second number is +12, -24, positive 48. So we've got a sequence that keeps changing signs on us, which is not a big deal when we're multiplying, because I can multiply by a negative number and change the sign of my product every time, right? So what negative number can I multiply into this sequence of numbers to get the next term? Okay, 2. Negative 2 times negative 6 is negative 12. Times negative 2 is negative 24. Times negative 2 is positive 48. So my ratio is negative 2. Okay, that's my formula. That is my geometric sequence nth term equation. Okay, first term, ratio, the a sub n and the n minus 1, like those pieces just go where they go once I find out what the first term and the ratio is, that number that I'm going to multiply it by. So if I wanted to use this formula now to find the ninth term, so the ninth term means that n equals 9. So all of a sudden this becomes a sub 9 equals negative 6 times negative 2 raised to the 9 minus 1 power. And order of operations is going to come into play here. All right, so the negative 6 doesn't change. The negative 2 raised to the something just happened. All right, the negative 2 raised to the 9 minus 1 or 8th power should probably be grouped if you're going to do that on your calculator. Otherwise you won't get the positive number that you need. All right, but we get positive 256, which then if we multiply by the negative 6 gives us our ninth term of negative 1,536. So that is the ninth term. Let me give you one to see what you can do. And I'm going to give you the formula again. So here's our a sub n equals a1 times r to the n minus 1. So that's what I'm giving you. Here's your geometric sequence. Ready, go. All right. So a sub n equals, so a sub 1 is 96. Our r ratio that we have to look for. So what number gets us from 96 to 48 to 12 to 24 to 12? It's easier to see once those numbers get a little smaller. It seems like we're using 1/2, right? So 96 times 1/2 is 48, times 1/2 is 24, times 1/2 is 12. So 1/2 is my ratio, my r. And so this would be my formula. And now if I'm trying to find the 10th term, now I've got a sub 10 equals 96 times 1/2 to the 10 minus 1 power. And some of this you'll go ahead and do. Some of you will figure out how to put this in your calculator all at once. Some of you will have to do it step by step. You'll all get to the same answer. And since we're calculating, and that is a verb, since we're calculating, a decimal answer would be just fine here. 0.1875. Okay. Now I do want to take one more problem and just walk you through a word problem and set this up. We won't work all the way through it, and we'll do a few more word problems in class. But I want you to see how we can read a word problem and pull out our first term and pull out our ratio to be able to set up the equation that then at some point we could go back and graph that exponential formula. Okay, so a sub n is going to equal, so if I read this question, the first number, the NCAA women's basketball tournament begins with, that sounds like a first term right there, 64 teams. In each round, 1/2 of the teams are left. So we get rid of half every time. So 64 times 1/2 would get us down to 32 times 1/2 would get us down to 16. So 1/2 as our r, and then n minus 1 just goes up top. Right? Now, again, we won't do this now, but when we get ready to graph this, this becomes y equals 64 1/2, and then the n minus 1, that's x minus 1. Okay? And that's how that would work.